come to a question which is, can the sum of two vectors of same magnitude, so can the sum of two vectors of same magnitude be equal be equal to either of the vectors either of the vectors in terms of magnitude. So the question is basically asking, if we have two vectors which are equal in magnitude, can there be such a case where the resultant is also has the same magnitude? So to understand this question, we would first of all have to find if this situation is possible. Um, so let's just do some general thinking. We know that, let's say one vector, we are just making a guess, okay? So this is just a guess, so I will use this gray color to symbolize a guess of sorts. Let's say the magnitude of vector A be 5, then since both have the same magnitude, then vector B must also have a magnitude of 5. And if you remember from the previous videos, the maximum magnitude that the resultant can have is the sum of these vector, which will be 10. So it will be 10. So if they are in the same direction, it will be 10. Whereas if the vectors are acting in opposite directions, then the resultant will be 0. This is the minimum case, and this is the maximum case. So that's the um, maximum and minimum with what maximum and minimum magnitude. So now, and we obviously know that any number between these two is also possible, so which means the magnitude of resultant might belong from anywhere from 0 to 10 in terms of magnitude. So just by looking at this, I can tell you that this is possible. So this is possible, but we need some sort of concrete proof. You can obviously you can also write it like this. You can also show the proof like this, where you go symbolically. But rather than doing this, let's find a exact case when this occurs. And why we are finding the exact case is for a simple reason, because another question that might come is, find the resultant of two vectors having same magnitude, which has the same magnitude, and find the angle on which they lie. So if I have two vectors, let's say A and B, and they have the same magnitude but different direction, and the resultant also has the same magnitude as these two vectors, so any one of these two vectors, then what would be the angle between A and B, so vector A and B? So that's a very interesting question, and that might be a very interesting puzzle. So let's try to find that as well, and I think that is much more appealing to me. So to do this, let's use the relation. So using the relation, so what relation we are going to use? The relation that we are going to use is the resultant, the magnitude of formula for magnitude of resultant, assuming that our two vectors are vector A and B. A squared plus, so the magnitude of the resultant will be the square root of A squared plus B squared plus 2ab cos theta. And let's say A and B are the two vectors, so let's write that as well. Let vector A, vector and vector B be the two vectors, and vector R be the resultant. So we also specified that. So now, according to the question, we know that there are two vectors of same magnitude. So we have vector A and B. So the magnitude of vector A and is equal to the magnitude of vector B. Since we wrote it like this, let's write it like that as well. So this will be A equals B in terms of magnitude. So now we need to find a case where the sum of the two vectors, which means the resultant in this case, so sum is the resultant, is also equal to either one of these vectors. So if r is my resultant, this will be equal to r. And now let's just put all of these over here. So I will do this in the next page. So we had r is equals to, so r will be represented by, let's say, x. Let's equal this to x and this let. So I'm assuming that this is x. So the magnitude of a, vector b, and vector r as x. Then we can write x equals to square root of x squared plus x squared plus 2x multiplied by x cos theta. So now what to do? So let's just square both sides. So if we square both sides, we get x squared, and also do some addition over here. This will be 2x squared plus 2x squared cos theta. Dividing everything by x squared. So dividing the left hand side and the right hand side by x squared, you will get 1 equals to 2 plus 2 cos theta. We are assuming that x is not 0, and we know that x is not 0 since we are taking two vectors of same magnitude. Of course the magnitude can be 0, but let's not go that far. We are just trying to find a case where the magnitude is not zeros of the vectors. That's why we are dividing. But in general sense, you can't divide these variables, since these variables, if they might be 0, that will cause you a big trouble. So we have this. So now what should we do? That's the thing. So let's move everything. So this will be minus 1 equals to 2 cos theta, and which means cos theta will be minus 1/2. And if I remember, or if you remember, cos, the angles of cos and what the value they give, we know that cos 120 degrees gives us minus 1/2. And of course another question that you might have is why 120 exactly, because of course you can add 360 to each of this, like you can add 360 over here and it will still be valid. It's because when we measure angle, we always try to measure angle up to 0 degrees to 180 degrees, so that's why we are doing this. Also let's write here, so since x is not equal to 0, of course x can be 0, but we are just saying that x is not equal to 0, since if you had two vectors of magnitude 0, since they have equal magnitude, if they both were 0, then any sum will just result in 0. So there is no angle that you will find. That's why it comes out something else. So now, and obviously if it was 0, so let's say x was 0, the magnitude of some vector was 0. If both the vectors was 0, then obviously the resultant would be 0 as well, and in any direction it would still be 0. That's why you get the complication. If x is 0, so let's also do that one. I think that's also a pretty fun challenge. So if x is equal to 0, then we can just say 0 squared is equal to 2 times 0 squared, 2 times 0 squared plus 2 times 0 squared cos theta, which just equals 0 times 0. So still this checks out. So I think I will make this part also gray. So this is also like my thinking process, you can see. Now we have this. So cos theta equals to cos 120 degrees, which must mean that theta is 120 degrees. So this means this is possible. So yes, it is possible. So before ending this video, since that's pretty much it, this is almost about it for the video, so let's do some let's actually draw some figure and see what we get. So I'm gonna take 3 units. Let's just take 3 units. Let's make it white for the first one and a lot more thicker like this. And let's take another. I will actually make this the resultant. I will make it a little bit faster, since this will be much more easier to explain once I do it. And I copied this once more. Let's make it blue, and let's rotate it. So I just rotated this. So this is exactly 120 degrees right now. So this is exactly 120 degrees. So let's just draw the parallelogram and see what happens. So this is not the resultant obviously, but let's keep that for size sake. So copy this, move it over here, copy this, move it over here. I'm also trying to see what do we get. So since this is also the first time I'm doing this, because I don't really prepare how to create the videos, I just make them because it's fun, and that's why it sounds like I'm just making stuff up, because I'm literally making stuff up as I go on. So that's why you find me talking about random stuff sometimes. So this is 3 units, right? And if I rotate this, this vector, and this vector are equal. Um, while looking at the picture, yeah, it seems about right, but if you really want to do it, you can take a scale and draw the figure and check it out. If you did some error, then obviously it won't be exactly the same, but if you don't make any error, you will pretty much exactly find that this, and this have equal magnitude. So that was it for today's video. A pretty short, not a pretty short video, but you understand what I'm saying. So in the next video we are gonna do another question. Till then, bye bye.